We're going to be looking at a related rates problem that involves two cars that are moving away from each other. We're told that two cars leave the same intersection at the same time. Down here in our diagram, this is our intersection. We're told that car A travels north at 45 miles per hour and car B travels east at 60 miles per hour. We want to find at what rate is the distance between the two cars increasing 2 hours later. The first thing we want to do is fill in some information into our diagram. Let's first think about car A. Car A is traveling north, so let's just label this car A. And then car B is traveling east, so we'll label this car B. And let's go ahead and let's put variables with this. Let's let car A be the variable y and car B be the variable x. Now let's write down the rates that we're given. We're told that car A travels at 45 miles per hour, so that means that dy dt is 45 miles per hour. And then car B is traveling east at 60 miles per hour. So that means dx dt is 60 miles per hour. We want to find the rate at which the distance between the two cars is increasing. So we need to go back to our diagram and we need to put a variable for that distance. And I'm going to call that variable z. So we want to find dz dt when 2 hours have passed. So this is when t is equal to 2 hours. Now what we need to do is we need to find an equation that relates x, y, and z. We can get it from the Pythagorean theorem because we have a right angle here. So that is x squared plus y squared is z squared. Now what we're going to do is we're going to take that equation and we're going to differentiate it with respect to time. So let's first write it down. We have x squared plus y squared is equal to z squared. Now we're going to take the derivative with respect to time of both sides, x squared plus y squared, and then we have d dt of z squared. This derivative is 2x times dx dt plus 2y times dy dt is equal to 2z times dz dt. Let's notice that our 2's are going to cancel. And let's go back here and see what we want to find. We want to find dz dt. So that's right here. So let's go ahead and let's solve for that. We can say that dz dt is equal to x dx dt plus y times dy dt, all divided by z. We want to find dz dt when t is equal to 2 hours. We're given what dx dt is, we're given what dy dt is, but we do not know what x, y, or z are equal to. But we can find those out because we know how fast they're traveling per hour, and they're going to be traveling for 2 hours. Let's come down here and let's figure this out. So when t is equal to 2, x is going to be 60 miles per hour times 2 hours. So that's going to be 120 miles. Y is 45 miles per hour times 2 hours. So that is 90 miles. And then Z, we are not given a rate for. So what we're going to have to do is go back to our diagram. I'll go ahead and recopy it right here. This is X, this is Y, and this is Z. And X is 120, and Y is 90. So Z is going to be the square root of 90 squared plus 120 squared. I'm leaving off units just for a minute. So this is the square root of 8,100 plus 14,400. And then this is the square root of 22,500. And that actually is a nice number. That turns out to be 150. And then we'll go ahead and put miles for our unit. So we have X, Y, and now we have Z. And we can go back up to here and plug everything in. So this is X, which is 120 miles, times dx dt, which we're given up top, was 60 miles per hour, plus Y, which is 90 miles, times dy dt, which we were given as 45 miles per hour. I'm going to have to write really small here. And we're going to divide all of this by Z, which we just found to be 150 miles. This is equal to 7,200 plus 4,050, all divided by 150, and we'll put units here in just a minute. This ends up being just 75. Now let's look at our units. Notice that our miles cancel out, so our units are just miles per hour, which is what we would expect. We can now say that the rate at which the distance between the two cars is increasing is 75 miles per hour.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.